Okay. So we have the stream going, and again, instead of playing a game, I thought we'd do a bit more of that dorky data science stuff that I like to do on my free time. And I figured since Lovecraft Country was just released on HBO, we could use network analysis to analyze his body of work and sort of see see the themes that will emerge. Try to surface some of the narratives in his work. I'm sure there's going to be a lot of racist stuff in there. We know how problematic Lovecraft was in his personal life. And there's been a lot written about it actually. I was just reading this article earlier today about how people try to grapple with this very, it's a complex, very problematic legacy. He certainly is one of the most influential horror authors ever. And you see his influence everywhere in video games and literature, role-playing games, and movies, of course, and all television. So you see that brand of cosmic horror everywhere. But at the same time, he was also extremely racist and extremely sexist. And, he's one of those people who, fans of his work can readily acknowledge was really just horrible in a lot of important ways. But yet they still appreciate the work, as well as all of the stuff that sort of came out of that work. It's made by other people, building off of what Lovecraft did. And it's something that I have not quite decided for myself what a proper andyan na siya. I'll be right back. Just give me a second. Yeah, okay, and we are back. Um, so yeah, like I was saying, Lovecraft, excuse me, Lovecraft Country has just come out on HBO. I watched the first episode last night, and I believe there's already a second episode out. And with Jordan Peele, I believe, as a producer of the show, you can be sure that um, race will be a big theme throughout the entire show. And I'm interested to see how they sort of try to unpack and deal with this, with all of the racism that was in many ways inherent in the work of H.P. Lovecraft, and that sort of informed it in many important ways. So it's interesting that people are somehow able to compartmentalize that and sort of set it aside when they appreciate his work, when they take it in. And he seems to be one of those people, one of those creators who somehow gets a pass for all of that problematic stuff. Who are other people like that? Maybe, I don't know, Woody Allen has certainly lost a lot of fans, but he still is revered as an important filmmaker. And many other people as well. But yeah, Lovecraft is definitely an interesting case. And so what I want to do today is to take his whole body of work and then run that through some network analysis, graph theory algorithms, as well as some NLP, natural language processing algorithms, and see what comes out, see if something interesting emerges from all of that. I found a dataset on Kaggle of his entire body of work of fiction. So all of the stories here are separated into individual text files, but you also get a big corpus text with all of the work put together in one big file. And that's probably what we will use for most of the analysis that I'll be doing now. Yeah, so that's the first thing. And then the second thing is, I also just saw that Kaitlyn Aurelia Smith, who is one of my favorite new composers from the past few years, has just put out, or at least this year, put out a new album. And I didn't realize that I was missing a lot of new releases over the course of the pandemic. Can't really pay much attention to everything that's going on when you're worrying about how precarious the current situation is. But I did see just now that she put out a new album. And so let's give that a listen while we analyze H.P. Lovecraft's work. So this is her new album, The Mosaic of Transformation. If you don't know Kaitlyn Aurelia Smith, let's Google her right now. There, so she's a composer who does kind of, I guess you could describe it as sort of experimental music, but it's not the most difficult thing to listen to. It's quite easy to listen to, actually. So as you can hear right now, it's very melodic, and it's not what you might call sound art that's very abstract. It's still full of very musical elements, but done in a very, it's certainly not pop. And she uses a lot of electronics, a lot of modular synthesis, as well as a lot of vocal processing on her music, which you can hear right now. Her new album is called The Mosaic of Transformation. She's done a bunch of different stuff, so you can see down here. She's also worked with Susan Shanty, who is an amazing composer in her own right. Yeah, so let's give that a listen and let's get to work on H.P. Lovecraft. So like I was saying, I downloaded this collection of text from Kaggle. So I have it over here. And all of the stories are in individual text files. And And then you also have this concatenated text file over here where it puts all of the stories just in one big corpus. And it has 46,326 lines of text. So yesterday I did a demonstration for how I use network analysis for semantic networks as well as text data. And so we'll be using a lot of the same techniques to analyze this body of work. I'm not endorsing any of HP Lovecraft's ideas. In fact, I find a lot of them abhorrent. Having said that, I have enjoyed a lot of the creative work that has come out that was directly inspired by him. So you have the stuff like the Call of Cthulhu games. I've run a bunch of role-playing games that drew specifically from HP Lovecraft's work. And I also enjoy a lot of the cosmic horror stuff. And Jordan Peele is a fan of the work somehow, but he's also keenly aware of how racist HP Lovecraft was. So, yeah, it's a bit hard to unpack, but that's that. Alright, so the first thing we want to do is to open up this piece of software called Powell. And what this does is it transforms a text file, no matter how big it is, into a graph, into a network graph that you can then modify and manipulate and analyze using network analysis software like Gephi or NodeXL or a bunch of other different things. So there are a lot of those out there. Gephi is probably the most popular one, and that's what we're going to be using today. Now, the first thing, once you've booted up Kowo, that I usually do is to go under the hood, and here I set some parameters that will help me make sense of the network that will be produced. So here you can set the number of words that you want to appear in the network. And the way this works is the software, the algorithm will choose the 250 most frequently used words that carry a lot of meaning, in the sense that they are not things like prepositions or articles or words that don't convey any strong ideas or concepts or meaning. So you want only the words that carry a lot of meaning so that we can surface the narratives and themes that are in the text. So that's what it does. 250 is usually a good starting point. I'll probably keep it at that. Sometimes when I go up to 500, 600, even 1,000, then you get a lot of, it clutters up the network. And we'll try to avoid that for now. A very important step is to select a list of stop words. Stop words are words that the software will ignore, that the algorithm will ignore when it determines which are the most frequently used words and phrases. So I have here, let's look at the file first. I have here a stop word list that is continually being expanded, and as you can see, this one combines Tagalog and English because I use it for analyzing Philippine news. And as you all know, we use both Tagalog and English in our local publications. So I'll probably just use this. I definitely will not need the Tagalog part of it, but there's no harm in throwing it in as well. And what the algorithm will do is it will ignore all of these words. So for example, it will ignore later, or however, or sorry, or specifically. And it will do that because these words on their own don't really convey a lot of meaning. We want to find the words that carry a bit more weight and that sort of drive the themes that we want to surface here. So we load up that list of stop words. Where was it? Here, data sheets. stop words. So we'll load that up, click on save, and then we select our text file of the stories by Lovecraft. So let's go to downloads. Where was that? I believe it's this one. Yeah. And we want to load up the file that puts together all of the stories in one text file. So that's this one over here, tomcat.txt. Open that, and then we create the map. And it doesn't take a lot of time, usually just takes a few seconds, so here we can see that it's already done the work. It took just 61 milliseconds, in fact. Well, more than that, but not a lot of time at all. And then if you go into the folder that contained your corpus, which is this one over here, you will see that it should have created a GML file. And a GML file is a graph file that can be read by Gephi or any of your network analysis software. So let's start up Gephi now. If you aren't familiar with network analysis, what it does is it represents things, objects, people, even ideas as nodes or vertices in a network. So all of these nodes are interconnected with one another. If you take a social network like Facebook, each of the users would be one node. And then we would have relationships with the people we are friends with, the people who follow us, and we would see a line that would connect each of those pairs of nodes. That line is called an edge. And what you will see in a network is a set of nodes and edges, all interconnected. So this allows us to see, for our project today, the relationships between the different concepts. Those are the words and phrases that Lovecraft chose to use in his body of work. So here we will open up the graph file. Okay, where is it? Let's go to downloads. And open up the GML file we just created. And as you can see, it has identified 250 nodes. Each of these nodes will be a word or a phrase. And it has also identified 7,903 edges. So what that means is, between those 250 nodes, there are 7,903 pairs of words that co-occurred with one another, meaning they appeared in the same, usually here, the way the corpus was organized, it's in the same paragraph. So if they did appear in the same paragraph, then they will be, have that link, that edge between them. So just click on enter, or on OK. And you can see here that it has identified the nodes already. So these are the different nodes. We see here fragment, friend, vapor. What is this? Air? Is it air? Power, rat, nightmare, blasphemous, plateau, ghastly, daemon, and other nodes. So these are the 250 most used or most important words in that whole body of text. And then there will be relationships as well between those different nodes. So we can see here that rat appeared alongside friend, and plane appeared alongside power, and voice appeared alongside sun. So that's what these connections mean. That's what these edges mean. Now we will want to visualize the network and make it look good and make it look understandable for an analyst like us. So usually you start out with a black mass like this, which is pretty hard to understand. Let's just move this up. Let's move this down. It's a pretty good album though. Enjoying. Okay, So what we'll want to do is to run some algorithms, and that will help us make sense of all of this. So first we will calculate betweenness centrality using this network diameter algorithm. And what betweenness centrality does is it measures the relative importance of these nodes. If you want to be technical about it, what betweenness centrality really does is it measures how often a node appears on the shortest path between other nodes in the network. And the way you can think of that is it connects different concepts together in a semantic or knowledge network. So that was a lot of jargon right there, but it's really hard to explain, to be honest. But think of a novel or a piece of fiction or a narrative, maybe a story, as different words and concepts and phrases, as different concepts are connected to one another. And then you would usually have big concepts, important concepts that serve as an anchor for the other concepts in the network. So for example, if we were looking at stories about COVID-19, you would certainly have COVID-19 as one of the most important concepts in that network, right? And its betweenness centrality would be very high. So what we want to do is to measure the betweenness centrality of all of the different words and concepts and phrases within HP Lovecraft's work. So let's compute that. Just click on OK. And then here we see a summary of its computations. I don't really need to pay any attention to this. I usually just close that. And then the next thing that you want to do is to run modularity analysis. What modularity does is it determines the clusters of concepts. In our case, it could be clusters of whatever you want really that makes up your network. In our case, it's concepts. So it will identify the clusters or communities of concepts have strong relations with one another, meaning they tend to very frequently appear alongside each other in the text. I usually like to set this at 0.6 for most of the text documents that I work with, but let's see what happens when I keep the resolution at 1. So it only gave us 5 communities. I feel it's way too little. So let's try to drop down the modularity a little bit. So here you sort of have to make a judgment call. I want to be a bit more specific than just having 5 large communities. So let's go with 0.6. And it gave us 20 communities. I think that's a good number to have. If you do LDA, which is another method you can use for topic clustering, topic modeling, you would usually find for this amount of text that if you set the number of topics to about 20-ish, between 20 to 30, then you get generally good results. So I think having 20 communities here is good. Let's close that, and then we can begin doing some layout work here. So if you recall, we generated 20, where we identified 20 themes or clusters, narrative clusters. So let's color code each of those different clusters. That. And click on OK. And then if you click on Apply, you will see that the color of the different nodes has changed to reflect which cluster they belong to. The next thing we want to do is to resize these nodes so that we can see which ones are more important. So if you click on this button over here, you can choose different statistics that will be the basis for the size of the nodes. So what I want to do is to use betweenness centrality, which is the statistic that we just calculated like a couple minutes ago. Click on Apply, and then you will see that we now have a set of very large nodes mixed alongside smaller nodes, medium-sized nodes, different sizes of nodes. And what the size of a node denotes is the importance, the relative importance of these concepts to the network. Now, you of course want to know what these concepts are, so you want to show the label. So if you click down here, you can check the node label, make sure it's seen. Do a bit of formatting here. I like to do that. Color, unique maybe. Let's go with let's just leave it. Let's just leave it as it is for now. Let's do that. Okay, and then we also want to resize these labels so that it's easier for us to see which are the really important concepts. So what I will do is to also sort or resize the labels according to betweenness and shadow. So you can do that. AIN. I wonder what that is. I feel that that's probably something that needs to be cleaned, because that's not a real word. Let me just do a quick search here. What is AIN? Okay, that might be a problem. Okay, I think we will just delete this. Sometimes it messes up and then it gets letters, not whole words. I don't know why that happens. I think it's something in the software, but most of these are real words, so I think we should still be good. Let's just get rid of the ones that don't make any sense. So if you worked with any amount of data, you will know that data cleaning is a very important part of the process. So we should still go through this and then maybe just delete some of these garbage words here. You normally will not want to do it this way, but this will do for now. So I'm just getting rid of all of the words that don't really mean anything. Just doing a spot check here. Wooden. So wooden is definitely part, I think the reason why this happens is a lot of this data science apps, they have problems with apostrophes. And so that's one very big limitation that they have when it comes to working with text. R definitely has a problem with apostrophes, which can be very frustrating. Okay. Alright, maybe let's do modularity again. Just to see. Okay. Okay. Alright, and then the next thing we want to do is to group together all of the different clusters that are related to one another. So I just installed this new algorithm that will allow us to very quickly bunch together the communities of words that have strong relationships with one another. So you could just go in here and then select modularity class, and if you run that, you'll see that it does it very quickly. Fur. It sounds like garbage there. Sat fur. Let me just look at the file again. Further different. I don't know why that happens. No, let's just get rid of fur. Let's get rid of fur. Again, this is another word that I'm not familiar with. Imagine. Yeah, imagine is different. You know, let's just make it imagine. Let's just do some manual correcting here. That should be imagine. Where is it? I'm fine now. Anyway, let's just not worry about that. Okay, now we could space out the nodes a little bit just so we can read the labels a bit easier. So we could do that. And then label adjust. Okay, now we can next lay this out as a chart. So if we go with the black background, rescale weights. Color should be white. It's definitely the hooded rat over here. Air. So what each of these light-colored clusters are is a sub-theme or a sub-topic that appeared in his work. So you, as an analyst of the literary text, you can just go into these and then you have a shambling mound over here, worn by. Right. Yeah, so each of these represents a subtopic from his overall body of work. I'm thinking we probably should have included a few more words here, but this is good for now. Yig. We have the hooded rat. Surprisingly, I don't see Cthulhu anywhere. Pearl's Ward, War, the Miskatonic, Arkham of course. I'm thinking I probably should have included a few more words. You know, let's do word on Paul Warden. Seeing as we had a lot of text, we can afford to put in a few more words. Okay, so let's open this up again. Go under the hood, and then instead of 250 words, maybe let's go for 500 words. Or you know, let's go for 700. And n-grams of up to 4 should be okay. Minimum characters per word, I'm gonna say, yeah, 3. It should be 3. And maybe I will not use my own stop words. Maybe the Tagalog part is messing up the analysis because I was getting quite a few garbage words earlier. So yeah, let's see what this does. So we should have a new GML file that we can open up. There, this one is a new one. So let's open that up. Okay, so now we have 700 nodes, so that's 700 concepts in the network. That's a bit denser. We also have 28,503 edges. Okay. And we'll do the same thing. So let's calculate network diameter so that we have the cleanest centrality that will allow us to find the most important words in this network. Let's look at the summary real quick. Okay. And then again, let's calculate modularity. Again, setting this to 0.6. This should give us about 20 subtopics, I feel. 25, that's fine. And then just recolor things again. Let's lay it out so that we can make sense of it. We had 25 topics, so let's color all of them and let's use yellow line. What does this look like? It's a bit hard to differentiate between them. Ooh. I don't like that. That is intense. Shade seems okay. Maybe let's use Target. And click on that, and then resize the node so that the most important ones are bigger. Apply. Resize the labels as well. This aim, what's this aim thing? Okay, let's just do a bit of cleaning. Okay, let's see, any garbage words that we want to take out. You know, aim is probably ain't, and like I said earlier, the software does struggle with apostrophes. So let's just delete that. Delete K, doesn't really mean anything. Miss, let's delete that. Okay, I think that should be fine. Okay. Alright. War seems to be a big theme here. And then let's do the circle pack layout again. There we have it. Expand. And then no overlap. And label adjust. Okay, now I'll probably just make these edges a bit thinner so it's a little bit easier to read. And let's generate the file. Let's give it a bit of time for work. Okay. Let's go with black background. 5. Scale rates. It's way too big. it's a bit tricky to find the right size for the fonts. It's way too small now. Let's go with 24. Way too small. It's probably good enough. Alright, let's just tighten it up a bit. So we use 24, size 24. No, we used 48. Do label just again. It's a bit hard to read. Let's dial down my thickness here. Or bring down the opacity. Okay, I think that's easy enough to read. Let's space things out a bit more. I would like things to be spaced out a bit better. And let's also change the palette. See what happens if we use force atlas. I really can't seem to get good results with these gravity-based algorithms, but they are favored by a lot of people. Maybe they don't work as well for text data. Multivariate. Different tool, maybe. And of course you could play around with the settings as well, but I don't want to spend too much time with this. You could order nodes by modularity class. And they are way too spaced out. looks nice, but it's really hard to understand. Not very useful, I would say. Circular layout. Let's see what this looks like. It's pretty much the same thing. Sorted by modularity class. Maybe 100 diameter size. Its diameter. Alright. Not very useful. The circle pack seems to be working well for us, so let's do that and sort it this way. And then we can just expand that. We'll expand it 3 times. And then maybe do some... Let's see what this does. Oh, so it ordered it by betweenness or by degree. We want to group nodes by modularity class though, and then order it by betweenness. That's pretty nice. I like that. So each of these spikes here will represent a distinct sub-theme from HP Lovecraft's work. Yeah, let's just play around with this bit and try to make it a bit more artsy. So let's see what this does. No, I don't like that. Ooh, that's nice. But maybe let's use a different set of colors. Yeah, let's use some different colors for this. Let's go with fancy. What does this look like? No, not very. Let's try this. Five. Aids. Yeah, let's try that. That should be readable on a black background, I think. I don't know why it thinks this will be reading the black background. Yeah, anyway, let's see. Let's see what it looks like. Okay, so we're getting a lot of overlap in the label, so maybe what I will do is to run label adjust as well as no overlap. So let's do no overlap first and then run label adjust. Okay, so that should clean it up a bit. It did mess it up though. I mean, it's not as pretty. Kind of like preferred the look of it before we did that. And then label adjust. There. I think that's what that works. I think that works. That's pretty nice. Let me just try to play around with this a bit more. What is transition? Smooth transition to layout. Very happy with this palette though. What is Tarman? Emir, what's up? Shout out to the boys in Melbourne. You know what's up? Ano bang pakinggan natin? Ano bang pakinggan natin ngayon, Emir? Ano to? Network analysis. Some data science shit. Okay, let's see what this looks like. Yeah, I think this looks nicer, so we could probably use this. And then let's export this to 16K resolution. Oh, okay, so I am getting flagged for the music on Facebook, so I think we'll have to switch to something that's more obscure. Let us listen to Soviet Wave again. Alright, so let us export this to 16K. Fifteen 360 by 840. DG Sonia, I'm here. Let's save it, save the graph. Kind of want to go for a more horror looking color scheme, so let's see. Person. Ice Cube. Indigo Nights. Wait. Maybe Indigo Nights. No. No, I like that. Maybe just Tarnish should be fine. Yeah, I'll just stick with that. Okay, so now that we have that, let's take a look at the file that we generated. There is still quite a bit of overlap though. Let me try to fix that. Let's run no overlap again. Label adjusts. It does tend to mess up these nodes over here. Maybe we'll just have to live with that though. Let's go for green. Is there a green palette here? Can't put this pink away. Yeah, let's try pink. Yeah, I think I prefer that. Export that. And then while that's working, we could also do some text analysis using Sketch Engine. which are it's like a set of NLP tools that you can also use to process text data. Okay, so it looks like my Facebook stream just cut out, but it's still probably streaming on Twitch. I think something might be up with my internet. Why is it 7? Okay, so we want to create a corpus of HP Lovecraft's body of work and run it through some NLP algorithms. So we use the same file that we used for network analysis. Put that in there. Give it a bit of time to process. Right, what should we this that will not get us flagged? I was listening to this yesterday, so I kind of wanna look for something else. I wonder if Mark only will get flagged. Let's do this go. I've already used 60 million words. Okay. So we can see here that the corpus for Lovecraft had 680,000 words. Now I just need to compile this. Should take a few minutes. Slow work. When did Marconi die? I believe he died this year, didn't he? Yeah, he died like last month. It's a pretty crazy year. Rest in peace to Chadwick Boseman. Alright, now let's take a look at what we have here. One interesting thing to look at would be word sketch. So this does part of speech analysis. We could take a look at our file over here and then see different words that were used to modify some of these words. So for example, we have war, right? And if you wanted to see how war was used in the text, you could just enter war over here. Let's try. That's right. King. What was the most important word here? It was king, rat, war. What else do we look at?